Good morning. Good morning, everybody, and welcome to 21st episode of Tech Forum. Tech Forum is a group of like-minded technocrats support each other and grow each other's business and other related activities. Today's presentation is a special one for the defense application. It's a use of trio laser for accuracy of the target for a longer distance. Though the present prototype have a range of 40 meters, but with the better laser, it can achieve up to 500 meters or even more. This is what the inventor says. The technology is patented. There's a patent ID. It was filed on 12th February 2019, and status is FER. So it is likely to get sealed, this patent, because fortunately no similar patent or objections so far received. So I'm sure Sanket will get the patent. So those who are from the defense background or defense industry, request them to watch this presentation carefully. In case you find it useful and interesting, you can always go for it. Sanket is open for both the options. Either he is ready to sell out this patent or try to join as a business partner. But that all will depend upon your mutual discussions and agreements. That's for the input of those who are attending. Without spending much time, I will request Mr. Vijay Iyer to introduce today's speaker. Over to Mr. Vijay Iyer.
Okay, good morning, all of you. Hello, can you hear me?
Yes, sir.
Yes, sir.
Hello, good morning, all of you. And welcome to this 21st Tech Talk in Tech Forum. Today's speaker is Mr. Sanket Bhosale. He's a young graduate from Pune University, 2016 in the mechanical stream. He has worked for Lear Automation for 1.5 years. Lear Automotive Company is a company making automotive seatings and electrical equipments. After that, he has switched over to Amphenol Interconnect India Private Limited, a multinational company making various sorts of connectors and cable harnesses. There are a huge range of connectors, MIL, DA999, Series 2, push-pull connectors, NPO connectors, and various types of connectors. He is working there in that quality department. He is also well versed with all the industrial techniques as value stream mapping, FOCO, OK, whatever technique you name, he is conversant with all that. Regarding his skills, he knows Xerox, Parametric 7, AutoCAD 2016, and Autodesk Fusion 360. His skills are like this, that whenever he sees a process which has got 3 Ds, dirty, dangerous, and difficult, it takes it a challenge to improve upon that process. So wherever the process is dangerous, difficult, or dirty, it's a challenge for him to improve the process. He visualizes a process, makes a concept, immediately converts it into a drawing format, and coordinates with all the tool room, automation people, and sees that is implemented. That is his skill. It's not on paper. So first of all, he identifies those things, makes immediately a drawing of that, coordinates with all those people, and ensure that is implemented. That is his skill. It's not on paper itself. In AIPL, he was handling customer complaints analysis and resolution of that. He has also installed vision camera system project for critical area in quality department. Now, coming back to today's topic, is trio laser arrangement to achieve a convergent target point more accurately. As informed by Mr. Rabde, it has already been patented, and FIR report also was there. The FIR report was nothing pertaining to technical issues. It was only something regarding to grammar and all that, and it is almost through now. Now, with this small introduction, I leave the platform to Sanket Bhosale to continue the presentation.
Hello everyone.
I request Sanket to start his presentation.
Am I audible to you, sir?
Yeah.
Hello everyone. This is Sanket Bhosale, and today I am introducing one new technology, one new innovation, which is pretty much interesting for you. The name of the innovation is a trial laser arrangement to achieve a convergent target point more accurately. You can see the images of that innovation. And I have done a short name for this MLIG. MLIG means the multi-laser integrated one. And I have taken a patent for the same. And you can see the patent application ID is a 201921005437. I have filed this on 12th February 2019. And current status of this patent is FER is already issued. And this month I have completed the FER requirement. And there are no, when I filed this patent, that time I was not hired any.
Sanket, you can switch off your video to take care of the bandwidth.
Is it okay, sir? Hello?
Okay, go ahead. Switch off the video.
I didn't understand. Hello?
No, switch off your video so that your audio will be more clear.
Okay, okay, sir. Okay, sir. One second. Is it okay, sir?
Yes, okay.
Yes, clear.
Okay. So, when I was participating that time, I didn't find an analytical. That's why I didn't know that law languages and all. And some of the grammatical mistakes are there. That's why they are in SDR. I have received only grammatical and a small errors are there. So that's why it is not difficult to take a grant on this then. So I'm going to explain before I'm explaining the further concept and the principles. I'm going to introduce one fact. When we play a game like PUBG, like IGI, Counter Strike, and all these games, we have one thing is common, and we missing that thing is a one located point in all the games, and that located point when we click the trigger button, that the perfectly hit that target. But in a real life, it is not possible because in a real life we don't have any indications of that gun angle, gun target point, and that judgment also. So if you want to judge that and if you want to achieve that accuracy, you need to practice more. You need to handle that weapon so many times, and you have to take a judgment of that instrument at that weapon. And after that, you can achieve that accuracy. But even after that, you cannot hit target more accurately. You cannot target it 100% accuracy. So that's why in a real life and the game, there is same one difference is that same thing, which is the indication of a target, indication of a location. Then I have doing same thing in a real life. We can attach the MLIG to the weapon. You can also hit the target like a gamer. There are some small adjustment knob also. I'm going to explain one thing. This is the structure of the MLIG. Firearm is there, and the MLIG is there, and the target is there. You can use the basic concept of the instrument. Further slides, I'm explaining to detail more. So MLIG is mounted on a gun barrel, any type of a shape of the gun barrel. I'm currently explaining for the guns also. Then further, I'm developing the same part. It means the same with the same concept, with the design only changes in design. It can be used for the rocket launchers and all missile launchers also. So prior art and why MLIG is required. Before I'm explaining how does it work and what is important, what is its requirement for our. And what are the prior arts? Difference between the prior arts and the MLIGs. The first point is the present way of the firing of the bullet firearm is the completely dependent of the capability of a shooter. If any shooter is not a well trained, then he cannot hit target properly. And even if he is a well trained, he cannot hit the target properly. Sometimes some of the psychological situation is matter, some of the mental situations matter. So many things are, so many errors are there, so many human errors are there, manual errors are there, just because of the he cannot shoot accurately. And the second point is the laser attached gun. You can see in this picture of the left side, one small laser is attached to the just offset distance from the barrel, and the second images of the gun is below to the barrel. Both cases, the laser is offset distance from the bullet axis. Bullet axis, it means where the bullet path, and this offset distance gives one error. And sometimes with so many times when we are in a military base, military areas, and any random environmental, there are a refractive mediums are there are a refractive index are there. That's why the lasers are deflect to the away from the target or apart from the target. So that's why offset laser, and this is not a perfectly indicator. It's just to indicate the direction of the target and not much more than. And the third point is that the cartridge itself is made so that it consists of a signal which will be show the target point. It means one technology are there where the first bullet is striking, that bullet is passing the return feedback to the second bullet where he wanted to the strike. But it is the AI technology. It is a much costlier, and still it is not that much effective as compared MLIG. So that's why I'm introducing you to MLIG. And MLIG is important for the society because important is the new world needs new technology. If current technologies are outdated or if it is that not much efficient, that's why we need the new technologies also. We have some technologies like AI technologies. Means when we strike the missiles and rocket launchers, they he lock the target, and by using the vision cameras and satellites, and that once he lock the target, he's the moving until the hit the target. But it is the AI technology is very costlier, and we cannot afford it all the time, because in a war and in the defense industry we cannot use all the time. And current products are not much that much effective because it's completely dependent on manual. And my fourth point is the most important point for this instrument: human error occurrence. The accuracy of the firing bullet is completely dependent on how the well-trained shooter is. If the shooter is, even if the shooter is a well-trained, if sometimes in a war situation, sometimes in unconscious situation, the shooter loses the mind, the shooter loses his control, and it may be shooter mental situation is not there. That time the occurrence of the error, that time the occurrence of the less accuracy is chances are that time less accuracy chances are more. So accuracy is the most important when you are firing the bullet, because you have to hit the target at the minimum time. That both things are matter. I'm explaining benefits the society and the country. First point is military application, and the second one is the security purposes. When we at a military base and military environment, there are fog are there, smoke are there, there are any so many things are there, dust particles are there, winds are there, and that's why heat vibes are there. So that all the environmental create one refraction, and that refractive index, he cannot judge the target. He looking if he want to achieve that target, he wanted to see that perfectly, but he cannot at least he cannot look perfectly, so he cannot hit that target. So MLIG helps you to MLIG helps you to control that the angle of the gun. And in a military application, the most important thing is I'm going to explain you. If suppose I'm giving one example. if suppose any rocket launcher requires the 3 bombs to hit the one tank, tank cost is suppose in a crore and bomb cost is suppose in a lakh rupees. But suppose if the three perfect target, the three perfect bombs can destroy the in crore rupees of tank. But if we use the single launcher having the 3 bombs, you require at least 4 to 5 launchers. It means we require to 4 to 5 means the 12 to 15, 12 to 15 bombs are there with less accuracy. Then that time the cost is not matter because tank cost is 15 and 20 crore and bomb cost is that time cost is not matter. But the required time to kill that enemy, required time to beat that tank, that 15 minutes tank will destroy your so many territory destruction, completely destruct your territory. That's why the accuracy is the most important in a military application and security purposes. Because once your enemy in front of you, once your target in front of you, you have to achieve that target in a minimum time. So you can achieve that target minimum point by using only accuracy only. In a rescue operation also you have only minimum chances. You have only 1 to 2 chances, at least one chances only to hit that target. If we miss that target, it might be you can miss the target after all the situations. And the toy investment and target purpose is also the helpful will be MLIG will be helpful for the society and the country also. The advantage of the MLIG as compared to the current technology and the current scenario of the innovation. The less operator dependency. In this MLIG, I have given provided one knob, single knob, which operates by single knob only, and it is not that much difficult, not a complex design, not a complex operator dependency. So that's why it is the very easy to handle. And once we current situation, if you want to hit by using gun, that time he wanted to his eye on the barrel angle. But in MLIG, he don't need to his eye and mouth onto out towards the gun. So this is the safety factor is also there, and the easy to operate gadget. And the third point is the mounting of any type of gun barrel. I have given a one mounting arrangement for that, so it can be used round barrel shape of any type of a shape. It's a round shape, elliptical shape, it's a circular shape, it might be the square shape. So any type of shape it can be mounted easily, and it's the most important part is to work in a refractive medium too. When the refractive medium in a refractive medium, a single laser diverted to the away from the target, but MLIG is a converted, is adjusted his angles and he locate the target properly. And it's a in size. This is also very compact, so that's why you can carry is also carrying is also easy. So how does it work? It's a simple geometrical concept converging a multiple rays to single target point, which is live on a bullet axis. In such a achieve using gear arrangement, even if the distance of the target is changed, the gear arrangement is given to the motion accordingly. As I said, I have given one a single knob. When we rotate that knob, it's converted that rotation to the gear to the lifting arrangement to the laser. I'll explain further, but it's a basic principle. We already learned about the right angle code. You can see in this picture, the slant height is L, the altitude is H, vertex is the top side, and the base and the R is the radius. So I have aligned with the exactly MLIG. The slant height L is the laser, H, H means the altitude is the bullet axis, and the vertex means target, and R is the radius. R is the radius. Radius is the difference, the distance between the laser source and the distance between the laser source and the bullet axis. So if we change that L, all the slant heights are equal in the right angle triangle, or the slant heights are equal, and we are using the same principle. If we check the angle between the L and H, if we change that the L and H, the H is increased, and if the L is increases, then the H is increases, and our h distance is our distance between the instrument and the target point. If we increase the length of the slant height, it means that we are declining the laser. And if we decrease the angle of a slant height, it means that we are reducing the length of the slant height. It means we are adjusting the towards it means the towards us. It means the towards the target. So this is the adjusting. We are using the basic principles of the cone, and that's how does it work. The conversion point move according to the away from the target, other the towards from the target. So this is one basic concept are here. How does it work? There are telescope is there to see the target, and the instrument having the three lasers at the relative angle 120 degree, and the center the gray line is a target, it's a bullet axis, and the three red lines are the laser. So you can see how they are it, and the in second images they are in ideal conditions, or the three lasers are parallel to each other, and all the lasers are converged to the bullet axis. And you can see the yellow wires are the wiring connections between the three lasers, and the bottom side the battery source are there. And it's also a single button operated in a current design. It might be changed in the future for the more development. Summary of the invention. The present invention comprised of the instrument which helps to achieve a target more accurately. The instrument indicates the target point, which is a conversion point on a bullet axis. In this first picture, you can see the conversion point is also a conversion point is a through the along the bullet axis, and all the converge at the single target point on the target. The instrument consists of three lasers placed at a 120-degree relative angle. In the second picture, you can see these three parallel lasers, and on the circular shape of the instrument, on the circular cross section of the instrument, the laser one, laser two, and the behind that the laser three. All the three lasers are assembled, and all the three lasers are mounted on the instrument at the 120-degree relative angle. The why three lasers I am using? Why three lasers? But the reason is three is the feasible solution. You can use the four lasers, you can use the five lasers, you can use the more than a six laser. I have taken a patent on that for the three or more than three lasers. But the feasible solution for the three laser, that's why I have used the three. For example, I give you one funny example. We know the table having a four legs. There are no need to add a fifth leg. It might be give it a structure hard, structure strong, but there is no need for the fourth leg. That's why I have used the three legs are comfortable. And another one thing is when we are working in a three-dimensional geometry in a vector, that time the two planes created on a single line. But when three planes are intersect, that created a single target point. And that's why I have used the three lasers are there, and there are two arrangements are there. There are more than two arrangements are there. There are first is the gear arrangement, and second one is the lifting arrangement. You can see the inside of this instrument. There are gears are there. Dual gears are there. They are total 5 to 6 gears are there. So we are using that gear for the rotational motion. When we operate the adjusting knob, you can see the below side, the black color, right side below. That's the black is the operating knob. You can rotate that operating knob. It's the converted into rotational motion to the gear, and first gear to second, second gear to third, and third gear converted it to the all gear. And this is the gear arrangement, and all and the end of the gear is the top of this gear, and all the three gears where are the laser are mounted. That's the upper side part is the lifting arrangement. That lifting arrangement converted is the rotary motion to the linear motion to the spindle. And in the linear momentum, the further is converted to the angular momentum. You can check this, the upper side, the laser are mounted with angular arm. Once this lifting arrangement lifts the arm, the lasers are declined towards the target. And if we rotate the knob away side, then it can be diverged from the target. And another one arrangement is spline and hub arrangement provided. It's working under the gravitational conditions. It means to the for the perfect muffing and the more accuracy. There are no pictures in here slime and hub arrangement because it is the inside of the instrument lifting arrangement. That's not that much important point here. According to the distance from the target of the instrument, the motion of the target adjusted the convergence point along the bullet axis or towards the target. Even if the distance of the target is changed, the convergence point follow the bullet axis and the target point locate it accurately. This is the one sheet are there. There are Excel sheets. This is the distance versus angle calculation. First column is the distance, second column is the angle in a radian, third column is the angle in a degree. The difference between the two distances, and the third one is the angle in a minute, and the same difference and further respective for the degree, minutes, and seconds. We are looking into the only first column and the third column, only A and C column. You can take the further. I have here calculation only for the 60 meters, but it can be changed by changing the laser. You can be achieve more than 500 meters, 800 meters. We have available laser of the 5,000 meters also. It may be 5 kilometers. So it depends on the laser accuracy and laser. It's a completely depend on the laser specification. That's why we can achieve the more than a target. But when I was with prototype, that time I used 40-meter trial taken. But according to theoretically, and it is the possibly by using the laser replacement, it can be achieve a target 1 kilometer also, 2 kilometer also. In the first column, I am using 1,000 for the basic calculation. 1,000, 2,000, all the dimensions, all the the unit is mm, and all the numbers are in a mm also. So 1,000 mm is the 1 meter to the 60,000 to 60 meter. There are a 60-meter calculation. I have specially add this slide because we can see the 21 number row and the 23 number row. There are 50,000 and 60,000. 50,000 means is a 50 meter and 60,000 means is a 6 meter. Sorry, 60,000 mm means 60 meters. So 50 meters and 60 meter. You can see the column number C21 and you can see the column number C23. It's a 89.93 and the 89.94. The difference between the angular change is a 0.01 degree for the 10 meters. And if we increase that distance, then it can be reduces or more, and it cannot be greater than 90. Then the fact is, you this is the we can be find one optimum distance to distance calculation. It means the 60 meter to 100 meter you can set it for 89.95, and you can 100 to 200 meter you can set it's a difference angle. This is a very minor small change. Sometimes you don't need to. It means the one. I think your question. Everyone having one question are there. Target are moving. Then is it not possible to adjust all the time? That's why I have add this sheet. This is not a all time you need to adjust that knob. You just need to adjust that knob. Then the target move away from the and the nearest near to us. Then you don't need to adjust all the time. You just adjust once in a once your target is visible, that you don't need to adjust that all the time. And that I have add the last point. Even if the distance of the target point, your convergent point follow the bullet axis and the target point located accurately. I have taken a proto for the same concept. So I'm going to explain how I work for that. This is one basic prototype. I am using some PVC pipe for the easy arrangement. And I that time I don't have actual pure charge here. As I learned in a school, I have used the compass and ice cream sticks and market laser. Easy to operate and that all. So I have it's a very basic level photo. Then I have modified it to the another by using extension to the target, and you can see the center lower side center photograph. This was the other are photos are the completely manual. The three lasers are there is no interlink between. There is no interlinkage between them, but the center below picture They are I have connected with the wire, metal wires, and adding one bearing at backside. And this was just for the concept trial. When we rotate that the backside knob, backside wheel, that all the laser are converge and diverge that time. So I have taken a trial, and at home I have taken a trial for the same also. You can see the first picture, the first, second, third, the three lasers are at a different point, and the bullet at away from the one relative angle is a 120 degree. And once we convert that, you can see second picture or the converge targets at the center. Center, it means towards at the target, and at the target means along the bullet axis. And in that time I have used this basic type of laser, so it can available that time is available easily, because I have trial taken in 2018 and 19. Then after that I have working on the for the further design. And this is the basic laser. And if we study, I have studied some laser, you can check this output power of the laser is a 10,000 megawatt. It's a very large, the maximum specification of this laser, almost maximum specification of the laser. The specification is other part is not that much important for us, but the laser range is 5,000 meters. If we use this the laser point, laser point pro lasers, if we use that type of a laser, if even if we use that specification laser, that the laser range is a 50 sorry 5,000 meters. Into 5,000 meters, it's almost 5 kilometers. So 5 kilometers is a that much enough range, because normally we are looking for the 1 or 2 or 3 kilometers, but the 5,000 is the more. Uh, I think it's enough for this instrument. And I have one video uh, for the trial. I'm sorry, the target 1,000 milliwatt. Yeah, sorry. The target parabolic rotation. The account distance initially velocity. How the gravity parabolic effect taken into account the distance initial velocity in long term. Okay. Target the burn distance measured by the initial velocity. Okay, I'll answer your question. Before I'm playing one video, please confirm the video is visible or not. Hello, video is visible?
Yes, visible.
Yeah, thank you. In this video, before first, you can see the three lasers are there and one plate are there. I assume that the plate is a target, and the center of the plate is a target point. And I have used the manually all. I operate all the lasers are manually. I operate the first laser towards the target is to follow his axis, and he's achieve the target. But we didn't understand where it is the meet. That then the second laser pass through it, and we got an inclined plane, and the third the point is to confirm the target location, and we achieve a single target point. In a refractive medium. Hello, am I audible?
Yes, you are audible. Video, I think video is over.
Yeah,
You,
yeah,
PPT is not being shown. Next slide, please.
okay, okay, 1 second. Refraction principles are there. Refraction of light. Everyone knows the incident ray. When the incident ray incident on a refractive medium, it's the decline or the inclined angle towards the normal. That's the same principle I have used in a also. But with a single laser are cannot confirm our refraction angle and the convergent point. But the three laser can be if the first laser decline with the 2-degree angle, second laser should be second laser also decline with the 2 degree and third laser also. Then even if the your refractive medium also it works. And the current status of the patent is the current status of the project is the IP status is the patent is already filed and status is first examination report has been issued and the design is completed but some of the different types of guns and I have studied for the more for I'm studying for the launchers and all some of the parts in the development phase you can be and the manufacturing not yet started because patent because the runningly I am working for the FER. So this is the last month for the FER. Then this month I have completed my FER and prototype as I shown in a figure and videos and photos. The prototype concept proto trial has been taken and second market worldwide and market in India. Worldwide, every country use weapons and ammunition, so demand of this product should be high everywhere in a wars and in a rescue operations. Everywhere the guns are used, the launchers are used, the rocket launchers are used, the bomb launchers are used. So that's why this instrument should be demand should be this instrument should be high and possible of the scaling up by using the international platform there are the chances of the international platform and patent platform. People can be connected to us and demand. They also demand for the product. So I am looking for the both. I am trying for the completely single time sale, and the second option is also partnership business also there. So I have choose the which one more valuable for me, and which is the more valuable for this project. And another one thing is my first opinion is should be it is a very interesting, but it is a very dangerous. Also. That's why I am my first priority is it should not be given to the wrong hand. It should not given to be the wrong people because the instrument if it is a good instrument, but is the use should be good. So that's why I am trying for the Indian defense and the Indian government because everybody having one attachment for your country and your military and everybody want to do something for our nation. So that's why I am trying to sell and I'm trying to manufacture for the India only. So this is my current opinion and the competitors. When I was received my FER, I have add one summary of the FER. That's why there are 3 points they given by approved from the patent office. Novelty, innovative step, and industrial applicability. And all of the 3 points they are completely yes said yes for them. It's a completely new. It is a novelty. It's a completely innovative. It's 1 to 11. All the claims are completely innovative and industrial applicability. All the so they didn't take any objection on a technical. If any if there is any objections of them, they can attach the one seated document for the same for for example any technology any idea is matched with the US and Russia and uh, China, and they can Canada, they can add that document. If your technology is matching with this, your claim is matching with this, your technology is a copy with this. That time, but I didn't receive any technical copy objections. I have just received objections. You can see my FER by using my application ID. This is only are just format related objections and grammar and the technical language and the law language. That's why it's not so difficult to grant them. And some of the attorneys are offered me for the help me to grant this in a single time. But my personal opinion is I don't hire any attorney. I'm doing it myself. And going forward to next 3 to 5 years, my primary goal is I would like to manufacture and market myself by using some giant manufacturers, and because of this accuracy, when the accuracy matters, the quality of the product will be matter. And my secondary goal is the collaborating with the similar product industry with the partnership, means which industry are manufacture the same type of instruments, same type of weapons, and same type of gadgets are there. So I'm working with that also. So I would like, I'm really interested to work on this project with those type of industry who are the giants in the market. If anyone has a question, please ask.
Okay, before we proceed for question and answer, we have Mr. Shirish Deshmukh, who is the president of Defense Electronic Manufacturers Association, and he will make his expert comments. Though your idea is good, it is a new idea. Your prototypes are there, but it is a very limited range. But you rightly said that it can be increased by using proper diodes. And you have demonstrated it to Mr. Shirish Deshmukh, who is the DIMA president. Let the DIMA evaluate your project, and if they find it is going to be useful for the nation, definitely they will take it up further. And it calls for a lot of changes, modifications in your present prototype and prototype you are going to show and demonstrate. So without spending much time, I will request Shirish Deshmukh to proceed with his expert comments.
Thanks, Vilasji, and thanks, Sanket, for excellent presentation. Your concept is really novel concept. We do appreciate it. But as I told you in the one of our meetings, that it needs to be put into real application. Then it needs some modification from the application and the user point of view. First of all, as you said, the accuracy. You said it is a pinpoint accuracy. But we have to find out with different weather conditions, under foggy conditions, or under any other environmental parameter, will it affect? So we have to find out where to evaluate that. I'm not sure whether you have evaluated it, because we didn't discuss anything on that. But any product that is going for the use of defense, the entire product needs to be evaluated, even the mounting and all that. We have to regularize it. From the noise, vibration, and harshness point of NVH, what they say. So under those conditions, how it will perform. Then also the recoil factor that we have to consider, whether your mounting arrangement will withstand the recoil of the gun. And if you see the 20-meter range gun will not have much recoil, but then there is no point in using this equipment for a 20-meter gun. What we need to use this for a longer distance. So as you said, your laser has got a 5-kilometer range. Forget about 5 kilometer, but at least for a 1 kilometer range, if we use, then the recoil will be substantial. And then the mounting arrangement needs to be done. And then where your equipment can be best mounted, so that it won't come in the path of a round or anything. So that needs to be evaluated, and that needs to be carried out with some experimentation. Maybe simulation will be required. Then deviation in laser parameters. All lasers, whatever you buy in the market, may not be of the same frequency, or they will have some deviation. So with that deviation, will the accuracy also affect? And is it will it be required to calibrate each and every equipment? And how to calibrate that? Whether the user will be having the sufficient knowledge and equipments to calibrate if at all it is required. So, and if the target is moving, then how you adjust your beam according to get in lock to the target. And if the target is moving fast, then is it some servo mechanism or some software which will lock on the bullet to the target is required, and how to implement that? So I think whatever I have learned and whatever we discussed, these points need to be addressed. But I'm sure that as the things progress, and DIMA will definitely help you in conceptualizing your product and approval for its approval, and some experimentation also required. So with this comment, I wish you all the best for your this product, and I hope you will go ahead with this and come up with a new concept, and which will definitely help our forces, and the product will be inducted into the army. So all the best for you. Thanks.
Thank you, Shirish, for the wonderful analysis. Yes, I know, because friends, before organizing this lecture, I requested Sanket to meet the president of DIMA, Defense Electronic Manufacturers Association, and let us get confirmation on the idea. So first thing happened was the president gave a positive signal about the technology, and hence we organized the project. But it is at the infant stage. It calls for a lot of modifications, testing, rigorous testing in line with defense requirements. And DIMA is definitely going to support the young scientist, Sanket Bhosale, and I'm sure he will succeed one day in his endeavor. And I'm sure India will have a weapon with a more accuracy as far as the target is concerned. So with this little comment, I will throw open the platform for question and answer. Most of the questions are answered by Mr. Shirish Deshmukh. So please ask questions if you have anything different. And Sanket, also see in the chat box, there are some discussions. So please identify yourself and shoot out your question.
मी बोलू का मेहता, सतीश मेहता?
बोला.
सर, एक म्हणजे क्वेश्चन मे बी व्हेरी एलिमेंटरी, आणि ते इट माइट हॅव बीन टेकन ऑलरेडी इनटू अकाउंट. तुम्ही ते डिस्टन्स वगैरे कॅल्क्युलेशन मध्ये दिसतंय, पण हाऊ दॅट आपण जे एलिमेंटरी ज्यावेळी आपण फिजिक्स शिकलो त्यावेळी आपण लॉन्चिंग व्हेलॉसिटी आणि डिस्टन्स वर त्याचं ग्रॅव्हिटीचा इफेक्ट आपण पाहतो, त्याचं पॅराबोलिक त्याचा प्रोफाईल येते. तर हाऊ दॅट इज टेकन इनटू अकाउंट, इनिशियल व्हेलॉसिटी, देन डिस्टन्स अँड दॅट पॅराबोलिक म्हणजे फायनल इम्पॅक्ट पॉइंट, त्याचे कॅल्क्युलेशन्स आपण काय करतो याच्यामध्ये? म्हणजे तुम्ही ऑलरेडी केलं असेल, पण ते कदाचित मला समजलं नसेल. आणि दुसरं म्हणजे पॉवर ऍडजस्टमेंट आहे का त्याच्यामध्ये तुमच्या इन्स्ट्रुमेंट मध्ये? इज देअर ए पॉवर ऍडजस्टमेंट?
एस इज इक्वल टू UT प्लस हाफ GT स्क्वेअर हा जगमान्य न्यूटन साहेबांचा फॉर्म्युला आहे.
तेवढंच माझं नॉलेज आहे.
हा, तर तो आम्ही त्याच्यावर थोडस डिस्कशन केलं की लेझरचा बीम स्ट्रेट जाईल, आणि याला तर काही गन्सला कसं असतं की रेंज ऍडजस्टमेंट साठी तुमचं माउंटिंग ते बदलतात. समजा म्हणजे 800 मीटरवर जायचं असेल तर लेझरच अशा प्रकारे त्याची ऍडजस्टमेंट केली जाते, फिजिकल ऍडजस्टमेंट, की तुमची गन उचलली जाते.
बर.
हा, तर संकेतशी ऑलरेडी माझं बोलणं झालेलं आहे. तुमचा पॉइंट अतिशय व्हॅलिड.
तुमच्या इशमध्ये डिस्टन्स मेजर करायची सोय आहे का असं विचारायचं मला, पल्स देऊन, पल्स रडार सारखी?
हा, नाही, ते कसं आहे, त्याला तुम्हाला LRF लेझर रेंज फाइंडर लागतो. हा, पण आता ही बुलेट आहे, पण जर तुमचं एरिया डिस्ट्रक्शन वेपन असेल तर तुम्हाला तेवढा अॅक्युरेट लागत नाही, कारण त्याची हे डिस्ट्रक्टिव्ह एरिया मोठा असतो. पण बुलेटसाठी डेफिनेटली जर ऑब्जेक्ट लहान असेल, पण आता लहान ऑब्जेक्टला जर तुम्हाला एखाद्या म्हणजे सॉफ्ट टार्गेटला जर बुलेट मारायची असेल तर बेसिकली तुमची गन 300 मीटर 400 मीटर एवढी लांब पाहिजे जाणारी.
बरोबर.
हा, गनची रेंज मोठी पाहिजे. जर गनची रेंजच नसेल तर लेझरची रेंज असून उपयोग काय? नाही,
बरोबर. आणि आणखी एक म्हणजे तुम्ही ते बोलताना बोललात 10,000 ते 10,000 मिलीवॉट आहे मला वाटतं, तुम्ही मेगावॉट बोलला असं ऐकलं मी.
हो.
ते 10 वॉट पॉवर ही सुद्धा पॉवर आहे. मग ते पॉवर ऍडजस्टमेंट ठेवली का तुम्ही कमी बॅटरी सेव्ह करण्यासाठी?
ते कसं आहे लेझर मध्ये वेगवेगळ्या पॉवर मध्ये भेटतात 10,000 मध्ये 10,000 5,000 6,000
नाही नाही नाही,
आता ते
तुमचा
कोणत्या
लेझर
टाईपच्या
नाही नाही नाही, 10 वॉटचा लेझर फिक्स आहे समजा तुमचा, परंतु बॅटरी सेव्हिंग करण्यासाठी तुम्ही काही लेसरची पॉवर ऍडजस्टमेंटची काही सोय आहे का? म्हणजे सपोज नियर ऑब्जेक्ट असेल,
10,000
आय मे नीड
10,000
ओनली
मिली
ओनली.
नाही 10,000 मिलीवॉटचा मी यासाठी टाकला होता कारण की 10,000 मिलीवॉटचा जो लेझर आहे ना तो 5,000 मीटरची रेंज देऊ शकतो.
नाही नाही
तर
ते
हा
मान्य आहे सर,
प्रोसेस
नाही 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 ते मान्य आहे, तुमचा 10,000 मिलीवॉटचा लेसर पाहिजे तुमच्या लॉंग रेंज साठी, परंतु समजा जवळचा ऑब्जेक्ट असेल तर पॉवर सेव्हिंग साठी म्हणून काही पॉवर ऍडजस्टमेंटची काही सोय आहे का?
10,000 मी मॅक्स साईड पकडलं होतं. ज्यावेळेस
नाही
आपण
नाही,
त्याला
मला जर
ऑप्टिमम लेवल
एकच वाट ट्रान्समिट करायचं असेल तर शक्य आहे का असं विचारायचं मला.
एकच आहे
नाही नाही, 10 वॉटच्या ऐवजी फक्त एकच वॉट ट्रान्समिट करायचा आहे, जवळचा ऑब्जेक्ट असेल तर शक्य आहे का?
त्यामध्ये
शक्य आहे.
अजून काही हे केलं नाही पण पॉवर सोर्सच्या इथे मी तेवढी डिझाईन साठी तेवढं हे ठेवलेलं आहे जिथे
अच्छा
आपण
अच्छा.
तिथे नीट लागून
हा
आपण
ते
त्याला
काय
access
माहितीये का,
करू.
हे मेहता साहेब, हे आता प्रोटोटाइप आहे आणि त्यात तुम्ही म्हणताय ते सगळ्या चेंजेस येणार आहेत फ्युचरिस्टिक, बिकॉज
Development
डीमा इज
phase
गायडिंग
मध्ये
संकेत. Okay, Lima
development phase
is
मध्ये आपण
behind
त्यावर
Sanket, so
ओके
not to worry on those questions. They can take care of it. Okay, any other question, please? आणखीन कोणाचे काही प्रश्न असतील तर प्लीज कम आउट. काय आहे, दिस इज एन आयडिया.
अरे सर, मी कुलकर्णी बोलतोय. आता त्यांनी जे अटॅचमेंट दाखवली त्याच्यामध्ये ते गिअर सगळे जे होते ते बेबल गिअर्स वगैरे वगैरे त्याच्यामध्ये गिअरिंग मध्ये खूप बॅकलॅश येतो, तर त्याचा याच्यामध्ये कसा काय हे घेतलेलं आहे कॉग्निशन्स एक, आणि या ऍडजस्टमेंट ही लेझर ऍडजस्टमेंट करण्याकरता साधारणपणे किती वेळ लागतो आणि तो डिस्टन्स डिपेंडंट त्याच्यामध्ये काही हे आहे का, वेळ आहे का?
येस, व्हेरी इंटरेस्टिंग क्वेश्चन. संकेत, नाही मग शिरीष देशमुख उत्तर देतील. Sanket, you have any answer for this?
Yes. Hello sir, can you see this distance of this angle calculation side?
येस.
नाही, एकदम डीम आहे स्लाइड, काही दिसत नाही त्या.
नाही, हे दिसू शकते, वी कॅन रीड इट.
Okay, I'll
मी बोलू का जरा?
No, my question was, sorry.
हा,
No, my
आता
question
काय
was
आहे
there are, okay, please go ahead.
आय अंडरस्टँड. एक मिनिट, हे जे कॅल्क्युलेशन केलेलं आहे ना, हे सगळं थेरॉटिकल आहे. थेरॉटिकल एकदा तुमचं प्रूव्ह झालं, पण फील्ड ऍप्लिकेशन मध्ये तुम्हाला हे जवानाला इथलं काही संबंध नाही, हे टेबल. त्यामुळे ही टेबल्स वगैरे हे सगळं आपल्या लॅब मध्ये एकदा कन्फर्म झालं की तुम्ही जी त्याला लेझर माउंटिंग द्याल त्याच्यामध्ये साईट किंवा रेंजचं ऍडजस्टमेंट द्यावी लागते आणि तिथे मार्किंग असतं. मार्किंग जवानाला हे कळणार नाही. जवान ते तुझं 300 मीटर म्हटलं की त्या दोन लाईनी मॅच करतो की ही 300 मीटरची रेंज, मग त्याच्यात काय व्हायचं, 300 इथं ठेवल्यावर 300 मीटर कसं ऍडजस्ट झालं हे जवानाला कळत नाही आणि तुम्हाला तशीच अरेंजमेंट द्यावी लागते फील्डवर, आणि ती सुद्धा खट असं 300-500 असं फिरवता आलं पाहिजे. तर ती अरेंजमेंट तुम्हाला करावी लागेल. हे बिवेल गिअर हाताने फिरवणं वगैरे जे आहे ना, हे तुमच्या लॅब मधल्या आणि वेपन प्रूव्हिंग साठी परफेक्ट आहे, पण फील्ड ऍप्लिकेशन साठी असं ते करत बसणं हे तेवढा वेळ नसतो. म्हणजे फील्ड याच्यामध्ये की जिथे डू ऑर डाय जिथे हे असतं तिथे असं डिस्टन्स वगैरे हे 1029 एवढे पॅरामीटर्स. तर हे आता थिअरॉटिकल संकेतनी जे केलेलं आहे हे थिअरॉटिकल प्रूव्हिंग साठी आहे. हे एकदा प्रूव्हिंग झालं की रेंज साठी मगाशी मी जसं म्हटलं तसं ते हाताने फिरवून ती रेंज ऍडजस्ट करायची आणि ती झाली की ती झाली असं समजायचं. त्या लाईनी दोन मॅच झाल्या की एवढं साध्या गोष्टीने ते करावं लागणार आहे.
जवानाला क्षणार्धात ते ऍडजस्ट करता आलं पाहिजे अशी टेक्नॉलॉजी डेव्हलप झाली पाहिजे.
यांना क्वेश्चन होता असा की त्या टाइम किती लागेल तो डिस्टन्स ऍडजस्ट करायसाठी, तर मी तेच केलं की
नाही, सांगितलं ना टाइम म्हणजे तुम्हाला फक्त बिवेल गिअर वगैरे काय आहे त्याला काही घेणं देणं नसतं. तो हाताने एका सेकंदात ते वरती खाली करतो, नॉब फिरवल्यासारखं. पंखा तुम्ही 3 वरून 4 स्पीडवर कसा नेता तशी रेंज बदलायची.
याच्यामध्ये जे अँगल आहेत ना, अँगल मध्ये खूप मायनर चेंजेस आहेत, त्यामुळे एवढा जास्त हे नाहीये की आपल्याला प्रत्येक मीटर.
नाही, बरोबर आहे. मिली रेडियन जे आहे, मग तिथं तुम्हाला ती यांनी जास्त फिरवलं कारण मी सांगतोय असं कारण आता आम्ही जे वेपन केलेलं आहे त्याच्यामध्ये आम्ही सर्व सिस्टीम लावली आणि ती मिली रेडियन मध्ये उचलली जाते फॉर 1 किलोमीटर रेंज.
ओके ओके.
हा तर 1 किलोमीटर रेंज साठी जर तुम्हाला मिली रेडियन मध्ये जर ते उचललं जाणार असेल तर प्रॅक्टिकली तुम्हाला अतिशय फाईन ग्रॅज्युएशन द्यावं लागेल किंवा वर्नियर वगैरे सारखं स्केल द्यावं लागेल की तुम्ही इकडं खूप फिरवलं फुल राऊंड मारलात तरी तिकडं तो मिली रेडियन मध्ये उचलला जाईल.
ते जे लिफ्टिंग अरेंजमेंट आहे ना त्याच्यामध्ये इन्स्टंट मायक्रोमीटरची कॉन्सेप्ट यूज केली गेली आहे.
हा
म्हणजे
एक्झॅक्टली
ज्यावेळेस
तेच मी सांगितलं.
मायक्रोमीटर ज्यावेळेस आपण स्पिंडल रोटेट करतो ना त्याच्या सिंगल रोटेशन ते खूप फाईन मध्ये रोटेट होतं.
एक्झॅक्टली मी ते
त्या टाइप
सांगितलं.
मध्ये अरेंजमेंट यूज केली गेलेली आहे. त्याचा क्लेम सुद्धा घेतला गेलेला आहे की
तर ते आता काय आहे बाकीच्या गोष्टी जेव्हा टेस्ट होतील तेव्हा
ऍप्लिकेशन सेल्फ टेस्टिंग रिक्वायर्ड आहे. Hello?
Okay, I think there's a good discussion and interaction on it. There is a lot of confidentiality also in this project where DIMA is supporting, but DIMA President Mr. Shirish Deshmukh have understood the concept and they are going to extend the support. कारण सगळ्या गोष्टी या ठिकाणी आता डिस्कस होऊ शकणार नाहीत. He has already applied for patent and there are a lot of intricacies involved in foolproofing the whole process. So आपण या ठिकाणी question and answer session थांबवूया. Unless somebody has a totally different question. तर एक शेवटचा चान्स देतो एखादा दुसरा. If you are having any specific but different question, please go ahead. Okay. I think
याच्या आधीची स्लाइड दाखवतो का आता दाखवलेली?
हा दाखवा जरा अगोदरची स्लाइड.
याच्या जस्ट आधी दाखवा. हा आता हे इथं जो माणूस बसून जे वेपन दाखवलंय 84 mm हे खांद्यावरचं. नाही ही स्लाइड. हॅलो.
हा अगोदरची स्लाइड. हा संकेत दुसरी स्लाइड पाहिजे त्यांना 84 mm गनची.
एक सेकंड ते हे होतंय नेटवर्क अनस्टेबल झालं.
हा तर हे जे आहे वेपन हा तर अशा वेगवेगळ्या ऍप्लिकेशन साठी हे वापरता जेव्हा येईल तेव्हा प्रत्येकाला वेगवेगळी त्याची माउंटिंग अरेंजमेंट द्यावी लागेल. कदाचित वेगळा लेझर वापरावा लागेल. हा
शोल्डर फायर.
हा शोल्डर फायर कारण प्रत्येकाची रिकॉइल ऍक्शन वेगळी असेल, प्रत्येकाची रेंज वेगळी असेल. तर हे सगळे एक्सपेरिमेंट आपल्याला करावे लागतील. आता ही यांनी जी कन्सेप्ट प्रूव्ह केलेली आहे ती कन्सेप्ट अप्रिशिएट करू आपण कारण त्याच्यावर बरेच अजून ट्रायल अँड एरर होतील.
We have to make a summary of this, what range is required, no? Make groups like this and find out.
Yes, I think as a tech forum and DIMA, we should appreciate Sanket's efforts, extend full support. Okay, because he's a very young scientist. He do not know what cannot be done or what can be done. He needs a lot of support in this endeavor. But this is definitely going to help the nation if the things are made in order and according to the defense requirements. This is what the DIMA president, Mr. Shirish Deshmukh, has commented. So I must thank everybody for supporting Sanket and participating in this discussions today. And Tech Forum, we support all such young scientists to make their dream in reality, because there are people who are our members who are expert and they extend their support for such young scientists. And as far as technology is concerned, there is no secrecy maintained by technocrats. They definitely support each other. Worldwide, when the television was under development, all the scientists from different competitions used to come together and improve the design of the television. So similarly, in defense application, DIMA team can extend the support and make this gun available to the Indian Army. So thank you very much for the nice participation. I thank you all, and exactly after fortnight, we are going to meet once again and we'll have another interesting lecture for the Tech Forum members as well as those who participate. So Sanket, thanks a lot. And thank you everybody
Thank you,
for
sir.
participation. Have a wonderful day. And we will meet after fortnight. Bye bye and have a
Okay,
nice day.
thank you, everybody.
Thank you, thank
Yeah.
you,
Thank you.
thank you.
Thank you, sir.
Thank you.
Thank you, Shirish, for your
Thank you all.
timely expert comments. Yes, thank you.
Thank you.
Thank you,
Thank you,
Vilasji.
Shiri Saab. I hear you.
Thank you. Thank